very important. So first of all, write MOP of ethers. In this, write number 1, dehydration of alcohols. Okay. Now, if your memory kicks back, you must remember this phrase dehydration of alcohol, because we have already seen dehydration of alcohol in the reactions of alcohol. And when dehydration of alcohol happened, we saw that it was giving us alkene. It was an elimination reaction. So how it is going to make ether? So please see here, we can do the dehydration at different temperatures, and it is going to give us different product. So please write CH3, CH2, OH. Now, if I do dehydration at a temperature which is high, at high temperature, it is going to give me alkene. So if you have H2SO4 and the temperature is 443 Kelvin, then you are going to get CH2 double bond CH2. Okay. So what is this? This is alkene, and this is specifically speaking, this is ethene. Now, when I do the same dehydration, that means I treat it with H2SO4, an acid, but I keep the temperature 413 Kelvin. Please don't write now. Okay. I have to tell something. Please don't write. 413 Kelvin, then I get CH3, CH2 bonded with oxygen, and then again CH2, CH3. So what is this? This is substitution reaction happening here, and it is ethoxyethane. So this was elimination. This reaction was elimination. And this reaction here, it is substitution. Okay. So what you should remember here is how to remember the temperature. So anything high temperature, it is going to be high temperature means it will be elimination. But if the temperature is 413, rather than remembering 413, what I suggest my students to remember is 414. Now, the reason behind 414 is it is like ROR. Correct? Yes or no? Please tell me, guys. I hope this will be easy to remember now. ROR is what? Ether. And to make ether, you need to have temperature 414. All of you guys will remember this. Yes or no? Please tell me.
Yes, sir.
Fahad Chavez. So at least you can remember 414. If you don't worry about 413. It's not very major difference, 414 and 413. But 414 is easier to remember for ethers. Just give me a second, guys. Let me get my earphone. I can't hear you, anyone. Just a second. Now, one thing you will see here is that one thing that you are going to see is if we are using any alcohol which is ROH, presence of H2SO4, that means any H plus, and at 414 or 13 Kelvin, then please see what we are going to get. We are going to get a symmetrical ether. We have R, which is bonded to oxygen, and then again R. So if I split the molecule between oxygen, then here also I am having the same alkyl group, and on the right side also I am having the same alkyl group. Okay, so oxygen is bonded to same alkyl groups, and these are known as symmetrical ethers. So please write here. Symmetrical ether. इसका definition लिख लीजिए पहले. Ethers having same alkyl group on either side of oxygen are called symmetrical ethers. Are called symmetrical ethers. Now, after this, you will write dehydration of alcohols. Dehydration of alcohols with concentrated H2SO4 at 413 Kelvin. At 413 Kelvin gives symmetrical ethers. Gives symmetrical ethers. Okay, so let us do some problems here. For example, if I have CH3OH and H2SO4, 414 or 13 Kelvin, then I will get CH3 on this side of oxygen, and that side of oxygen will also be CH3. So no matter what group it is, whatever the alkyl group present in alcohol, the same alkyl group will be present on either side of the oxygen in the ether. Okay, please write, this is first one, write the second. 2 carbon atoms and OH, H2SO4, 113 Kelvin. It is a yeah, just a second. So please write these two questions and then we will look at the mechanism. Anyone still writing? Please let me know. Achha, once you are done, you will send the answers on my WhatsApp. Huh? So I'm going to give you guys 3 more minutes. Then send the answers on my WhatsApp. Yeah, I've got one answer. Yes, very good, Aram. Correct. Others, please send your answers. Shahid has sent me. Yes, Shahid, correct, very good. Chavez, yes, correct, very good. What about you guys? Madiha and Faiza is here today. Yeah, Faiza. Faiza and Madiha, please send your answers. Also, Tari, Fahad. Guys, please send your answers. What happened? Madiha and Faiza. Madiha, you're not able to do this? Madiha, please answer me quickly. No.
Sir, actually,
Yes.
I don't have my phone right now to send the answers.
Okay, fine. What about you, Faiza? Faiza, what happened? Are you stuck? Are you not able to do this? Faiza has sent. Tarif has sent. Okay, send it quickly. Yeah, very good. Tarif, that is correct. Very good. Faiza, you're taking so much time. Abaya. Didn't get the last one. ठीक है, कोई बात नहीं. See here, Faiza. See, you have to identify what is the alkyl group. So this is my alkyl group. Okay, so you'll make this. This will attach with what? Oxygen, and then again the same thing. Okay, as here, what is the alkyl group? This is my alkyl group. So you'll have one like this, and it is bonded to oxygen. Then again the same thing. Got it, Faiza? Yes or no? Please tell me.
Yes.
Right, next mechanism. This mechanism is important. They can ask you directly, write the mechanism of dehydration of alcohol to form alkene. That is also important. To form ether, this is also important. Please write here first of all. We are going to look at the reaction of CH3 bonded to CH2 and OH, that is ethanol, in the presence of H2SO4, concentrated H2SO4 obviously, and 413 Kelvin. It is going to give you CH3, CH2, oxygen, CH2, and CH3. Now, let us look at the first step. So in the first step, we will be having the alcohol as it is, OH, with its lone pair electrons, plus there will be H plus ion, plenty of H plus ion because we have concentrated H2SO4. Obviously, this H plus ion, it is very electron poor. It is having positive charge. That is why the lone pair electron will attack on the H plus ion like this. And this is going to give us a protonated alcohol. That means the oxygen atom will be having 2 hydrogens and a positive charge. But please remember, it is still having a lone pair electron. Okay, so it has only donated 1 lone pair electron. So there is 1 lone pair electron just still there. Now, let us move on to the another part. We obviously, not all the alcohol will get converted to protonated alcohol, right? So there will be some alcohol that have not come in the influence, or they have not attacked on the H plus, they have not met the H plus yet. So we will look at those alcohol. So you have OH like this, plus our protonated alcohol. Now, here comes the crucial part, which may be confusing afterwards. Right now, I will explain so you will remember it. Okay, you will understand it right now, but later on, you will be having some doubt. Oh my God, what it is happening or why it is happening like that. So please listen. Now, there are 2 attacks that generally most of the students they expect. There is one attack. Most of the students, what they do, they see lone pair electron, which is having electron rich species, will attack on electron poor species, that is oxygen atom. But is the oxygen atom really electron poor? Let us see. Let us see whether it is really electron poor. So I have oxygen atom, which is having 3 bonds, 1, 2, and 3 bonds. And there is also a lone pair electron. Even though it has a positive charge, that doesn't matter. But it has a lone pair electron, right? It has only donated 1 lone pair electron. So it is having 3 bonds as well as a lone pair. What is the meaning of 3 bonds? The meaning of 3 bonds is 1, 2, 3, 4, 5, 6, 7, and 8 electrons. Now, since oxygen is already having 8 electrons in its valence shell, it is having 8 electrons in the valence shells. Its octet is complete, and it is also of period 2. That means the maximum valence shell that it can have is the second shell. Second shell is the valence shell, and the valence shell has 8 electrons. It cannot accommodate further electrons. So obviously this oxygen is not electron deficient. So what about this charge, sir? I will say this is formal charge you have learned in 11th standard. This is just a formal charge to compare the positives and the negatives. That means to compare the number of protons and the number of electrons in the valence shell. That charge, it is not telling us anything about the electron deficiency. Is this clear? Yes or no? Please tell me.
Yes, sir.
सबको ही बताएं, ठीक है? So obviously this attack is not going to happen. It's never going to attack on the oxygen atom which is bonded, which is having 3 bonds. Even though it has a positive charge, which is just a formal positive charge, but it is not electron deficient for sure. But imagine, just imagine living in the neighborhood of oxygen atom. That itself is going to make this carbon atom very much delta positive. If it was pure oxygen, then also it would have been delta positive. Now that oxygen, it has a positive charge. So it will be pulling more electrons from the carbon atom, making this carbon atom very electron deficient. And that is why the attack will happen onto this carbon atom, the alpha carbon of the protonated alcohol. Is this clear? Yes or no, please?
Yes, sir.
Now, please see. Now, when I look at this, when an attack happens here, this bond will be broken. The carbon will say that, okay, oxygen, tata, bye-bye. I'm not going to bear your positive charge now. So H2O will be removed and you will be having, please see, this oxygen atom. This oxygen atom was having the lone pair, 2 lone pair electrons. One of the lone pair is still available. And it is now bonded to this carbon atom, which is further bonded to this carbon atom. So it is bonded to one carbon atom. This is the alpha carbon of the previous protonated alcohol and the other carbon atom, which is attached here. Now it already has hydrogen. So that hydrogen is still there and it is now going to get a positive charge. It is now going to get a positive charge. Okay, so this is the attack of nucleophile which is happening. So this is acting as a nucleophile. Why it is acting as a nucleophile? Because it is attacking on the carbon atom. It's attacking on the carbon atom. Now listen, the next step. Now we just need to remove the hydrogen. So it is known as deprotonation to form ether. So deprotonation will occur. We have positive charge here. So this hydrogen atom, it will break bond with oxygen and it is going to give you a simple neutral ether. Okay, so the electron which are present in the bond, it will neutralize the oxygen atom and you will get H plus ion. Now you may ask, sir, sir, why is this hydrogen so happily giving electron? This is happening because H2SO4 will have a conjugate acid which is known as conjugate base HSO3 negative. So actually this HSO3 negative is going to attack on the hydrogen atom. Okay, or maybe what can happen? Many things can happen to this particular hydrogen atom. Another thing that could happen to this hydrogen atom is, wait a second, we can have another alcohol molecule which can attack on this H, right? So another alcohol can also attack. So what will happen eventually is the hydrogen will be liberated as H plus. So these are the 3 steps which are happening. So wait a second, let me just write the names of these steps so it will be easier for you guys to remember. So this first step is what I can say, it is the for protonation of alcohol, I would say. Protonation of alcohol. The second step is attack of nucleophile. And the third step that we are having at the end, this is deprotonation. Deprotonation. Is everyone done? Let me know. All of you done now? Anyone still writing?
Sir.
Okay. Let me know once you're done.
Sir,
Bole?
sir, in
Done.
that second step, attack of nucleophile, how did that oxygen get positive charge, like in the product?
So can you please repeat what you said?
Sir, in second step, in when oxygen is sorry, in product, how did that oxygen get positive charge?
This oxygen. This
No, no,
oxygen,
sir.
right?
That third one.
No, I mean, yeah, for sure. But this is the same oxygen, na?
Yes,
This
yes,
oxygen is this oxygen, right? So see what is happening. It is donating a lone pair electron, na, form a bond. Correct. So
yes, sir.
this lone pair electron is lost, na? That is why.
Okay.
Okay. So whenever oxygen, see, just remember this rule about oxygen. If oxygen is making only one bond, then it is going to be O negative. It is making double bond like this, then it is going to be neutral. If it is making two bonds like this also, this is also double bond, right? Two bonds for oxygen. This is also going to be neutral. But if it is making three bonds, it will always have a positive charge. Okay. Similar is the case for nitrogen also. If you have a nitrogen and nitrogen is having triple bond, so it is neutral. If it is having double bond N and a single bond, then also it is neutral. If it is having three bonds like this, it is also neutral. But as soon as nitrogen has four bonds, now 1, 2, 3, and then one more bond here like this, it is going to get a positive charge because it is making this bond by donating the electron pair, the lone pair electrons. Actually, if you are done, then we can write some remarks. Write remarks. First point you will write is, it is an SN2. It occurs via, it occurs via SN2 mechanism. And the rate of reaction will be, please write rate of reaction. Rate of reaction. So what happens in SN2? Methyl alcohol will be fastest. Methyl alcohol. Methyl alcohol is CH3OH. So it will be fastest, followed by 1 degree, followed by 2 degree, and then followed by 3 degree. Then yes or no, please tell me. Yeah, option. Now, since the rate of reaction is what it is, fast for 1 degree and it is slow for 3 degree, please write. What else you can write here also? Also 2 degree and 3 degree alcohols. 2 degree and 3 degree alcohols tend to form significant amount significant amount of alkene as they are more hindered. Hence, this method is only suitable for the formation of formation of symmetrical ethers using 1 degree alcohols. Also write next point. this method is not suitable for the preparation of unsymmetrical ethers, as it would require two different alcohols and lead to a mixture of products difficult to separate. I will explain this. Please write this down. So it is not suitable for the preparation of what? Unsymmetrical ether. What is unsymmetrical ether? For example, I have ethyl group on one side and I have methyl group on the other side. Now, let's suppose I want to make this particular ether. So what I would do, I would take one alcohol with ethyl group and one alcohol with methyl group. So I will take ethyl alcohol and I will take CH3OH, methyl alcohol. I will treat this in the presence of H2SO4 and 413 Kelvin, right? Now, I expected this product, I expected methoxyethane or ethyl methyl ether, but what would actually happen is, please listen very carefully, there will be some ethyl alcohol. There will be some ethyl alcohol which will never meet the methyl alcohol. They will react with themselves and form ethoxyethane. Similarly, there will be some methyl alcohol which will never come into contact with ethyl alcohol, and or rather what would happen is, before coming into contact with ethyl alcohol, they will come into contact with methyl alcohol only. They will react with themselves and they will form methoxymethane, or I write CH3OCH3. Okay. There will be some ethyl alcohol which will meet methyl alcohol, and both of these, when they are going to react with each other, then they will form our desired product OCH3. Okay, so I hope you can see that it is very bad that it is not the method for the preparation, because it is going to give you like one of the three product is my product, one of the three product is my product, the other products are not the desired product. And also one more thing, one of the three product is my product and it will be my product only after I separate them. Now, obviously these are completely what? All of these are slightly polar molecules. They will be having similar boiling point. Why? Because they are having similar molar masses, not very far away from each other. And then next, what will happen if the boiling points are not very different? We will not be able to distillate them. We can separate them, but those separation method will be very costly. So basic method of separation that you should know is steam distillation. If something can be done by distillation, that is the easy method of separation, we could do it. But the separation for these ethers will be very difficult because they are having similar molar masses, they will be having similar polarity and similar boiling points. So we cannot do distillation in this case. Is it clear, guys? Yes or no? Please tell me. Anji, बताएं.
Yes, sir.
Now there is a I mean this same सवाल जो है ना, why it is not suitable, उसको बहुत ही अजीब तरीके से एक बार पूछा गया था, वो हम सवाल लिख देते हैं आप लोगों के लिए, ठीक है? So you may not be worried. Please see here, for example, just you have not written, my bad. लिख लीजिए. That I can type the question. So I think the question goes something like this. Can you explain why is bimolecular dehydration is not appropriate for the preparation of ethyl methyl ether? ठीक है. Now this bimolecular dehydration, बच्चे इसी में परेशान हो गए थे, ठीक है? I hope now it is going to be easier for you. Now, I hope you can see that it is the same question. If I ask something like why this method, why dehydration of alcohol is not a suitable method for the preparation of unsymmetrical ethers, है ना? And this question, both of them will be having same answers only. I hope all of you can see that, yes or no? हाँ जी, same answer होगा ना? Right guys, yes or no? क्या ख्याल है? नहीं ख्याल है? Let's change the color. Can you explain why is bimolecular dehydration is not appropriate for the preparation of ethyl methyl ether? है ना? तो बिल्कुल यही सवाल था जो हम लोगों ने जो रिएक्शन वगैरह सब कुछ लिखा. So your basic answer should be because it would lead to a mixture of products difficult to separate. That is the basic answer that you have to write. Nothing else. Okay? इतना लंबा जवाब नहीं लिखना. Obviously you are not going to write. I'm not going to write the answers here. आप लोगों को पता चल गया क्या हो रहा है फिर पे. चलिए आगे बढ़े. आया ना बताएं. Now the next reaction is very important. Please write. Second one. From alkyl halides. Alkyl halides. Bracket में लिखिए a name reaction which is Williamson ether synthesis. Williamson ether synthesis. Right here, when haloalkane is treated with suitable sodium alkoxide and SN2 reaction takes place, forming corresponding ether. Okay. So first of all, how to get sodium alkoxide? It's very easy. I would react alcohol with sodium. Alcohol reacts with active metal to give alkoxide ion, right? RONA. Plus, we will get what we will get H2 gas. Okay. So now we have this alkoxide ion. So we'll use this alkoxide ion, that means RONA plus some alkyl halide R-X. Now this oxygen atom, it is going to attack on the alkyl group like this, and we are going to get RO from the alkoxide. Just a second. From the alkoxide, and then R- from the alkyl halide. Is this clear? Yes or no? Please tell me. याद रहेगा सबको? हाँ जी. इसके बाद जरा आप लोग एग्जांपल्स लिख लीजिए. तो first step Na. Second step, let us suppose we have Br like this, 2 carbon atoms. So identify the alkyl group in both the cases. What is the alkyl group in alcohol, or alkoxide can also be present. Okay, don't worry. For example, you can have something like this also. ONA, and then you can treat this with, for example, CH3Br. Right, third part. ONA, CH3I. Try these 3 products. I will give you 4 minutes would be enough, I think. Please write it down. Identify the alkyl group in alcohol or alkoxide. Identify the alkyl group in the alkyl group in the haloalkane. Remove the sodium. Add the alkyl group from the haloalkane. Okay. I'm waiting for answers, guys. Yeah, correct. Correct answer. Very good. Others, please send your answers. Sorry. Yeah, first and second one is correct, Tariq. Very good. By the way, third one आपने नहीं भेजा, तीसरा. Right? Third one you have not sent me. You have sent me only 2.
Sir, I have sent the third one.
Yeah, Tariq you have sent. Sorry, Shahid has not sent. Oh, what about others? Faiza, Matiha, Shavez. Chavez has sent. Chavez, first one is fine, second one is fine. Yeah, very good. Third one is also correct. So you guys please see. So you just need to identify the alkyl group in alcohol and the haloalkane. No? So please see. So one alkyl group is here, ethyl, and here is also ethyl. So 1, 2 carbon atoms, oxygen, and 1, 2 carbon atoms. Here we have ethyl and then oxygen, so oxygen, and then I will add a CH3 here. Now here I will make all the things as it is with the oxygen atom here, and what alkyl group will be attached on the oxygen CH3 from here. Is this clear, guys? Yes or no? Please tell me. हाँ जी बताएं. सबको clear है?
Yes, sir.
So let us move a bit forward. By the way, थोड़े और examples आप देख लीजिए अगर आपको कोई complexities लगे ना यहाँ पे देख लीजिएगा please. And then I will have 2 carbon atoms like this. ठीक है? चलिए. Now, right next remarks. As we have seen and previously said that Williamson ether synthesis is an SN2 reaction, है ना? SN2 reaction. WES is an SN2 reaction. Is an SN2 reaction where alkoxide is nucleophile and Rx, that means the haloalkene, is substrate. Okay, is the substrate. Now that means the alkyl. That means what I can say. If I talk about the haloalkene, then the haloalkene should be less hindered. Therefore, the haloalkene, because it is a substrate, वहाँ पे attack हो रहा है, right? The haloalkene should be less hindered. It should be less hindered. Then you will write next point. कैसे लिखें इसको? That it should be less hindered. So when we are making unsymmetrical ethers, no, तो इस तरह से लिखते हैं, to form unsymmetrical ethers, alkyl halides used should be preferably 1 degree alkyl halide. Okay, write this down. And there is a very good question in NCERT to practice Williamson ether synthesis. So we are going to look at those questions and then we will end the class. चलिए इसमें ना एक और पॉइंट अगर आप लिखना चाहें ना, यहाँ पे वी राइट वन मोर पॉइंट, यूसेज ऑफ 2 degree or 3 degree haloalkane leads to the formation of alkenes as they are more hindered. ठीक है, usage of 2 degree 3 degree lead to the formation of alkene as they are more hindered. Another thing is, please write next, which is important. See, if I want to form, please understand this and then we'll write the point. If I want to form a alkoxybenzene and any R group like this, okay, any R group like this. So please understand, here we are having 2 alkyl groups, right? So we have the R group. Let me rather write it like this. This particular thing can be made by 2 different reactions. I can either make it by using ONA plus RX, or the another way of going towards this would be aryl halide plus I will add RONA, right? But please remember that this method will not be successful. Why? Because when the oxygen atom is wanting to attack on the alpha carbon of alkyl halide, it won't be able to attack because the aryl halide, they don't show nucleophilic reactions. They don't show nucleophilic substitution reactions. That is why we have to use phenoxide ion and haloalkane. Rather, we should not be using aryl halide and alkoxide. Okay, so what we should do? We should use phenoxide ion and the haloalkane. Is this clear? Yes or no? Please tell me. Hanji, बताएं.
Yes,
You
sir.
understand the? Okay, fine. If you understand the problem, then you can write it also. Please write next point.
Second scroll up.
Just a second. Let me write it down. Then I will let you. So please write here alkoxybenzene cannot be prepared using alloarine and alkoxide ion because alloarenes don't show acid. Therefore, alkoxybenzene are prepared using sodium phenoxide and haloalkane. ठीक है, आराम से लिखे. You can also make this. ठीक है, आप इसमें यहाँ पे ऐसे टिक कर लीजिएगा और यहाँ पे क्रॉस लगा लीजिएगा. Done, guys? Yes or no? Please tell me. No, still writing. Anyone still writing? Anyone still writing? No, no one is writing.
Done, sir.
Please write the question. Write the names of reagent and equations for the preparation of following ethers by Williamson ether synthesis. Now, first step of doing these type of problem is going to make the structure. So 1-propoxypropane. 1-propoxypropane. So what is propane? Propane is 1, 2, and 3 carbon atoms, and it is having a propoxy group. That means it is having oxygen with 3 carbon atoms like this. 1, 2, and 3 carbon atoms. Now this is a symmetrical ether, so you don't have to worry. This can, so this you have to just identify which alkyl group should come from alkoxide and which alkyl group should come from the haloalkane. Now since it is symmetrical, you don't have to worry. We can write the reaction for this will be, please see, 3 from the alkoxide and 3 from the haloalkane is going to give you propoxypropane. मामला खत्म? हाँ या ना, जल्दी बताएं. All of you understood this? Yes or no?
Yes, sir.
बोलो भाई, कुछ हार्ड तो नहीं है. चलिए अगला देखिए. Please see next. Ethoxybenzene. So ethoxybenzene. So what is benzene? Benzene is benzene, and it is having what group? Ethoxy. Oxygen bonded to 2 carbon atoms. Now tell me which fragment will come from which reactant. So we have 2 ना, ethoxy and benzene. ठीक है, चलिए आप लोग ये बता दें बेंजीन कहां से आए. बेंजीन किसके पास से आए? सॉरी, बेंजीन आरएक्स से आएगा या फिर अल्कोक्साइड? हाँ, फेनॉक्साइड से आएगा. कहां से आएगा? एल्कोक्साइड, यानी कि वो फेनॉक्साइड हो जाएगा. राइट, वेरी गुड. सो विल बी फ्रॉम द फेनॉक्साइड, दैट मींस ONA. बाकी लोग को समझ आ रहा है नहीं आ रहा? You can write BR or you can write anything else also, है ना? I am not very biased towards BR. You can write I also. That doesn't matter. All of you got this? Yes or no? Please tell me. हाँ जी बताएं. अरे बोलो भाई. Write this third one. नहीं आया समझ शायद ना. मदीहा, फायजा, फिर से एक्सप्लेन कर दें. अरे बोलो हाँ या ना तो बोलो कम से कम। मदीहा, फायजा, तारीफ, शाहिद, शावेज तो ने आंसर दिया है। फहद, अंडरस्टूड द सेकंड वन, यस और नो? मदीहा अंडरस्टूड, व्हाट अबाउट अदर्स? फायजा वगैरह अंडरस्टूड ना सबने? चलिए ठीक है। तीसरा देखिए, तीसरा इज वेरी इंपॉर्टेंट। ओके फाइन, आई होप यू अंडरस्टूड। See, 2-methoxy, 2-methyl propane. So first of all, I will make the parent, that is propane. So 1, 2, 3 carbon atoms. 2-methyl, that means it is having a CH3 group in the second carbon atom. And it is also having a methoxy group in the same carbon atom. OCH3. Okay. Now we have here, let me make it a bit properly, okay? This may look a bit confusing to you guys. So I should make it like this. So I have 3 carbon atoms like this. As you can see, this is my 3 carbon atoms. कौन सा दिया इसको बनाया था भाई पहले, इसको बना दिया हमने. So we have these 3 carbon, 2, 3 carbon atoms. This is my methyl group and this is my methoxy group. Okay. So now tell me, this methyl group should come from what? Alkyne halide, RX or R only? Chat में बताएं सारे लोग. This methyl group will be coming from RONA or RX. Should be coming from RONA or RX. Tell me guys. This methyl group should be coming from which fragment? चलिए, शाहिद करेक्ट, वेरी गुड. तारीफ करेक्ट, वेरी गुड. के फाइजा, waiting for others. Madiha, send your answer. Shaviz has not sent. Shaviz didn't give the answer. Shaviz, okay, fine, Shaviz, okay. Madiha, you have not given an answer. Faiza, can you turn your mic on? Yes, Faiza. Faiza, can you turn your mic on? Faiza, am I audible? Can you please turn your mic on? If you can't, please tell me that you cannot unmute yourself. No response. This is really like, I don't know what happens to students like this. Fine. Faiza, your answer is wrong. Madiha, you have not answered. Please see how to do this. How to identify? Please see. Identify the degree of the carbon atom. So this is 3 degree. And this is 0 degree or 1 degree, right? You can say 1 degree for 0 degrees also. And we have already said that the haloalkane should be less centered. To form unsymmetrical ether alkyne halide, use should be preferably 1 degree alkyne halide. So whatever is 1 degree alkyl group, that will be the RX. So for this reaction, for this particular product, I need ONA, and the CH3 will be coming from the halogen atom. Then you have methoxyethane. So methoxyethane is not a problem. So fourth one is methoxyethane. 1, 2 carbon atoms, oxygen, and then this is methoxy, and then you have ethane. So obviously the smaller part that should be coming from the alkyl halide. ठीक है, ये याद रखिए. छोटा portion है वो कहाँ से आएगा? Alkyl halide से. So this bigger part will be from alkoxide and CH3. We have the smaller portion will be smaller fragment will be from the alkyl type. I will get oxygen and CH3. Please copy this down. Let me know once you're done. If you have not written the previous ones, please see and write. Okay. Let me know if anyone's still writing, or else we will write one question, please. Why di-third butyl? Di-third butyl ether cannot be prepared using Williamson ether synthesis. Now, to answer this, we should see the structure of di-third butyl ether. So what is tertiary butyl? You have 3 carbon atoms attached to 1 carbon atom like this. Just now this carbon atom, this is tertiary carbon, right? It is having CH3 here, it is having CH3 here and also here. Oxygen atom. So this is a tertiary butyl group. So one more tertiary butyl group will be here. CH3, CH3, and CH3. Okay. So this is di-tertiary butyl ether. As you know that when in Williamson ether synthesis, one of the alkyl group should be coming from haloalkane. Right? One of the alkyl group. Now, since both of these are same alkyl group, but the problem is both of these are 3 degree. And we know that if I react a 3 degree haloalkane, then it is going to give us alkene and we will not get ether. That is why di-third butyl cannot be prepared. You will write here since both alkyl groups has 3 degree carbon atom. Therefore, no suitable haloalkane can be used since 3 degree haloalkanes will give alkenes on reaction with alkoxide. Is everyone done? Yes or no? Please tell me. काफी हो गया. Started from subject and -8. Is everyone done? Yes or no? Please tell me.